Okay guys, welcome back. And now essentially we are planning to just finish the journey that we had for the Bayesian hierarchical modeling, adaptable for the Alzheimer's dataset that we had. At this stage, we are just going to write the stand codes for it. We're just going to introduce more than 3 levels into our existing model. But remember, this one is going to be computationally extremely expensive, and it may take a couple of days to execute the codes on your system, even more than a couple of days. However, we're just going to write to see the systematic way that we're just going to write the codes. Then, depending on the power of your system, you feel free to just execute that on your system to see what wonderful results you just may get at the end. The levels that we're just going to introduce is going to be this. Previously, the levels that we had for the brain atrophy of the samples that we had, that they just came to our clinics, for example, we just introduced the levels of if those patients are dementic or non-dementic. I mean, if they have been identified with the Alzheimer's disease or not. And we also did one more deeper level to introduce one level of the hierarchy into our model, and we said that what's going to happen if those persons who have been identified with the Alzheimer's, they have some variations within which stage of the Alzheimer's they are in. For example, these are the stages that we discussed, and we said that, for example, that can be with the mild cognitive impairments, the mild Alzheimer's, moderate Alzheimer's, or the severe Alzheimer's. And we were able to just introduce that additional level of the hierarchy into our model and see that the level of the brain atrophy, even with those patients who are suffering from the Alzheimer's, is going to be even with different rates and different variations when it comes to this level of the hierarchy, which is, I should say, these 4 additional levels depending on the CDR scores, which the participants in that study, they have obtained. Now, and the questions that we just want to ask ourselves right now, and we just want to find an answers to all these questions, when we write the stand model, and when we execute the model, and we just take the samples, I should say, from the posterior distribution, and take the mean of all those estimates, is that what happens even if those patients are dementic, have been identified with the Alzheimer's, and we know that they are, for example, at the severe Alzheimer's disease, at that phase, at that level of the hierarchy, at the severe stage, is the rate of brain atrophy between women and men, it's going to be the same, or that's going to be different. I mean, if the gender plays a role in the level of the brain atrophy, if someone has been identified and diagnosed with, I should say, severe Alzheimer's disease. And you can see and you can feel that there is one level of additional, I should say, hierarchy and a source of variations in, I should say, in our study. And also, you may ask another question, the question that we also raised at the beginning. Imagine that we focus on those groups that they are suffering from the severe Alzheimer's disease, and we have chosen the gender. Is the level of the education plays a role? And for example, can we say that the people with the high school diploma, they are gonna suffer from the higher rate of brain atrophy when, for example, they are, for example, under our study, compared to someone who has, let's say, for example, who has a postdoctorate. Or you can see that there is a variation that we can introduce into our model depending on the level of the study and the changes of the brain atrophy rate depending on that level that we are looking into. And also, for the last question that you just want to ask, imagine those people who are diagnosed with the severe Alzheimer's disease. If that person is, I should say, at the highest social economic status, they are just gonna experience a lower rate of brain atrophy compared to someone who has, let's say, for example, at the lower, I should say, ends of the social economic status, that we assigned a score for that, and we have been able in the R session that we had to categorize it and find the intervals of those persons and those patients in our study group then. And now we are just going to answer all these questions in a multi-level Bayesian analysis, but the first step is that we should be able to just find and write a most suitable, I should say, Bayesian codes in this stand. And that's the thing that I'm just going to do it right now. In order to do that, I'm just going to throw your attention to a systematic way that we're just going to do. And in order to do that, we are just going to first of all define the data sets that we had. If you remember from our data sets that we have been able so far to find our data sets as the way which it is, and we define the model D, but however, in order to introduce one more level of the hierarchy, we have to just design a kind of a data sets in our study. I'm just going to pause the video for just a couple of seconds and reload the data set. It seems that they have been just erased. I just get back to continue when it's done. I just uploaded the data sets again. I executed the codes which I written for the data again and just took care of the missing data. Another thing is that I'm just going to create the data itself. I'm just going to call that data stand. I'm just going to call that model. We have been able to just go all the way to the model D. I'm just going to call that model E for this purpose. You remember that from the things that we discussed, we know that for the stand, the data that we're just going to introduce as an input for our data sets, it's going to show up as a list. In order to just go ahead, I'm just going to, in order to show that the systematic way which it's going to be done is that I'm just going to copy paste the prior level that we had for the data. I'm just going to copy paste it here. I only simply are just going to change the name of the model that I have, the data, but still it's going to be a list. However, at the end, I'm just going to add the necessary and the new objects that's needed in order to run our full and new hierarchical Bayesian analysis for the Alzheimer. We're just going to introduce different levels into our model. The first one, we talked about the gender, whether they are just going to be men or women. In order to show that, in order to show the gender, I'm just going to call additional objects. I'm just going to call that M, stands probably for the male. And I'm just going to check the number of the levels for the male. And I'm just going to extract the data which referred for male or female, which you see that it's going to be the M.F. M stands for the male, F stands for the female, and I'm just going to assign objects called M to show that the number of the levels for the M and F, which probably guess it's going to be 2, because either we have M or either we have F as male or female. And also, the other objects which I'm just going to create, it's going to be the MF, which is going to be essentially the index of the people in our study. For example, we have 373 observation. We are just going to tag individual observation by either F or either M. Then when you look at those data sets, and you do not see the face of those people to see that if they are female or male, and you do not know what's the name they have, you can check with this in tag, and you see that this is tagged as M or this is tagged as F. And that's the purpose of writing this code. I'm just going to write as integer, and I'm just going to again go to the data sets which I created with the M and F. Okay. By doing this, essentially, I'm done by creating additional level of the hierarchy simply in order to define my data for that purpose. Now, you remember that we also have to add another level of the hierarchy, which is going to be the education. You remember that we just defined an interval for the level of the educations by the functions find intervals, and we assigned between 12 years of education, 14, 16, 18, 20, and so forth. And now, as a result, I'm just going to call another object, E stands for education, and I'm just going to go ahead with the number of the levels, and I'm just going to say for the data, I'm just going to extract the level of the education, and it gives me the level of the education which I expected. Remember, if you hadn't done the categorizations of the education, you get 0 for the level. And be very careful when you just want to do that. And also, The other thing that we are just going to have, essentially it's going to be this. I'm just going to put educ, and I'm just going to go ahead and put as integer. As an integer, I'm just going to put, I should say, the data. I'm just going to put the $, and I'm just going to put the education. It's going to be the second level of the hierarchy, but at the same time, if you haven't done that so far, we can also come before and define these levels of the things which we have created. I can just go ahead, data, I can put, I should say, the $. I get the male and female, and I just put the factor in order to just put it in the different levels that I have, and simply I just put the data and also M and F. I execute the code and I get this one as a factor. And now we can get the number of the levels that we have. And also, I'm just going to do the same thing for the other levels that we had. It was for the education. I just put the factor of, I factor it, I should say, in terms of to get the level of the things that we have categorized, again by the data, and I extract the data by the educ. And also, I'm going to do the same thing for the next level of, I should say, the hierarchy, which I'm just going to introduce, which is going to be socio-economic statutes, and I'm just going to put the factor, I should say, into that categorical data which I have created in order to get the n levels of it not equal to 0. I should have done that before when I just create a list, and now I did it right now, and that's essential when we just define, I should say, the level of, I should say, the data as a list for our, I should say, for our data sets. Remember, these line of codes, in order to factor, it's essential for the variable and the predictor that you're going to define another hierarchy into your model. Then you do not need to just factor any features that you have. This is going to be only relevant for the cases that you have to introduce one level of the hierarchy based on the variations that you're going to see within that features in your data sets. And also, I'm just going to continue for the socio-economic statute. I'm just going to call it S. I'm just going to call that N levels, and data, I extract the socio-economics, and that object is created. Because I put the factors for the socio-economics, now I get the level of the factors based on the thing which I defined it previously on the previous lectures when I categorized the socio-economic factors by using the find intervals function based on the scores which people got in that study. And also another object which is going to be, I should say, as tagging the people in our data sets to see that which level of the socio-economic status they belong to when I'm just going to look at each observation and I see a tag is attached to it. I'm going to execute the line and you see that this one is going to essentially be a data which is going to be an input data for your stand function when you just write your stand function and choose the level of the number of the iterations in your data sets to just converge your model, then just sample from your posterior distribution. This is going to be essentially that data that we are looking for. However, make sure that you save it before you just move on. Now the thing that we are just going to do essentially here is that we are going to create the same type of the data sets, and in order to just create, I should say, a model block and essentially a stand find for the model that we are creating with multi-level Bayesian analysis. It's going to take, I should say, more time in order to fill out, I should say, this stand find, but essentially it's a systematic way in order to introduce, I should say, different blocks, minor changes, by learning that you're going to able to just create stand finds and write stand finds when you can also add more than 100 levels of the hierarchy in your model in order to just go back and to see what is that clue, what is the best thing, what is the best strategy in order to write your stand model. Even if you have hundreds, I should say, of the level of the hierarchies, that's going to be the topic when we come back, and we are going to see that how spectacular that strategy is going to work out. And essentially at this stage we are done by creating the list of the data for understand. When we come back, we talk about the standpoint aspect.